We're talking about solving exponential and logarithmic equations. And for solving this logarithmic equations, we want to exponentiate each side of the equation. If we're looking at example C, first thing is we have some log rules, properties of logs that we can use. And for this one, we have log base 10 on both sides joined with addition, so we can rewrite that as multiplication. So we can say log base 10 of 5x, and that's going to be multiplied by x minus 1, and that is equal to 2. Then we can distribute the 5x into the binomial, and we get log of 5x squared minus 5x. At this point, we have the log just on one side, and so if you have the log just on one side, then we can exponentiate each side to help solve the equation. And again, we want to pick whatever value it is, we want to pick one that's going to help us out. So we understand that this is the log base 10, and so we want to exponentiate each side by raising it above the number 10. So down here we'll say 10 raised to the log of 5x squared minus 5x, and that's going to be equal to 10 squared. The reason that we did that is because 10 raised to the log base 10 is just 1. And so we end up with, we just end up with 5x squared minus 5x, and that is equal to 100. Now we have a quadratic equation because we have x squared, and there's a couple ways we can solve it. One way that we can try to solve it is we can try to solve it by factoring. So that's what we'll do. In order to factor this, we need to have one side of the equation equal to 0. So we can subtract 100 from both sides, and we get 5x squared minus 5x minus 100 is equal to 0. We notice that all of these are divisible by 5, so we can take a 5 out. And so we get 5 times x squared minus x minus 20. And now we can factor this. And so we get 5 times x times x. And we need to make it equal to negative 20. So we need to have a positive and a negative. And the negative has to be bigger because we're left with a negative here. So 4 and 5, that'll work. So 4 has to be positive and 5 has to be negative. Then we can use the zero product property. And the zero product property says whatever makes this part 0 is going to make the whole thing 0. So x can be equal to negative 4, or x can be equal to positive 5. And now we have to check and make sure that each one of these work. And so we just substitute it into the original equation. And we can say log base 10 of 5 times 4, or negative 4, plus log of negative 4 minus 1. And we want to see if that's equal to 2. And when we go ahead and do that, we get the log of negative 20 plus the log of -5 is equal to 2. And then we get the log of 100 is equal to 2. And so even though we do get the value of 2 here, we can't take the log of -20. So 4 is not going to work for this one. And then we'll take a look at x equals 5. And so we're going to do the same thing. Log of 5 times 5 plus log of 5 minus 1. That's going to be equal to 2. So we get the log of 25 plus the log of 4. And then we get the log of 100 is equal to 2. So 10 squared is equal to 100. And so we're all set there. So our issue for this one comes up with our two functions here. We have the log of a negative value. So then we're looking at the next one. And we have, we got to use our gemdes again. So we're going to work backwards to get the natural log by itself. So the first thing we have to do is subtract 3. And then we get the natural log of 7x minus 4 is equal to 6. And then we can exponentiate both sides of the equation. So we want to say, because its natural log is base e, we want to say e to the natural log of 7x minus 4 is equal to e to the 6th. And e to the natural log is 1, so we just get 7x minus 4 is equal to e to the 6th. Then we can add 4 to both sides. And we get 7x equals e to the 6th plus 4. And divide by 7. And we get x is approximately equal to 58.2. And that's a pretty close estimation there. And we need to check to make sure that that one will work. This is an approximation, so we want to use the exact value up here when we substitute it in. And so we want to say the natural log of 7 multiplied by e to the 6th plus 4 over 7. And then we can subtract 4 plus 3. And we want to check to make sure that that is indeed equal to 9. And when we distribute that, that goes into 7 here. And so what happens is the 7's cancel, and we're left with the natural log, 7's cancel, e to the 6th plus 4 minus 4 plus 3 equals 9. 4, positive 4, minus 4, those cancel out, and we're left with the natural log of e to the 6th plus 3 equals 9. And then we have the natural log, so we can take the value out of the exponent, and the natural log of e is 1. So then we get 6 plus 3 equals 9, and then we get 9 equals 9. So that one does work. So x is the solution. X is about equal to 58.2 is the solution here, and x is equal to 5 is the solution here.